Our goal for this lecture is to find the graph of our trig functions. So we're trying to plot sine of theta and cosine of theta. So as usual, we will start at the unit circle. Remember that for the unit circle, our x-coordinate is equal to cosine of theta, and our y-coordinate is equal to sine of theta. As the point makes revolutions around the circle, how does our y value change? This point D represents the value of the y-coordinate, and it seems to be oscillating between two numbers. It goes all the way down to -1, and then it goes up all the way to +1. This point E represents the value of our x-coordinate, or cosine of our angle. So, as our circle makes revolutions, E bounces between two numbers, the same two numbers that D does, -1 and 1. This means that sine theta and cosine theta both have outputs between -1 and 1. Or in other words, the range of sine theta and the range of cosine theta is -1 to 1. Notice how we use brackets here and not parentheses. That's because both sine and cosine can evaluate to 1 or -1. If sine and cosine's outputs are between -1 and 1, then what are their inputs? Well, it's the angle theta. And is there any limitation to our angle input? Well, not really. We can have positive angles. We can have angles in the form of decimals. We can even have negative angles that rotate our terminal side clockwise. Since there are no bounds to what our inputs can be, the domain of our trig function is -infinity to infinity. Remember, anytime we write infinity in interval notation, we always use parentheses. Now, let's trace what these functions look like. Let's start with the sine function. So we're only looking at the y-coordinate. As we input different values for our angle measure, notice how our graph moves in a wave-like pattern, moving between -1 and 1. Something to note is that the graph of our sine function crosses through the origin, or point 0, 0. For cosine of our function, our graph also moves like a wave, but notice that it does not cross the origin. It crosses at point 0, 1. So sine of our angle looks like this, and cosine of our angle looks like this. If we draw them right next to each other, we can see that they're pretty much the same thing, except with a little shift, either to the left or to the right, either way you want to think about it. The last thing I want to point out is some critical points. Here, we have one portion of our sine curve. After this, it just keeps repeating. We call this one cycle, and it has 5 critical points. 1 point where it has a maximum, 3 points where it hits the x-axis, and 1 point where it hits a minimum. These critical points happen at 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, and 2 pi radians. Or in other words, it happens every 90 degrees. At 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Cosine of our angle also has 5 critical points. 2 peak points, 2 middle points, and 1 low point. If we put our graphs together, we can see that each critical point occurs at the same input. Keep this in the back of your head. They come in handy. We're going to be using this a lot.